So let's talk about domain of a function. Some functions, like a line, would have all reals. We can have any x and it would be fine. But some functions have restrictions on them. For example, a rational function. Think about it as 1 over x. That would be a rational function. But we know that x can't be 0, or it would be undefined. So we have to watch out for what happens with that x. Or let's say we had a radical. So the square root of x. Well, we now know that we can't have negatives under the radical, so x would have to be greater than or equal to, because it could be 0, greater than or equal to 0. So when you're looking at problems, you need to decide where is x, and then any kind of restrictions do I have, if any. So when we look at just x, y is equal to x, these all probably should have been y equals. When I look at y equal x, then I know that x can be all reals. There's no x that I can't just, even if it were 2x, I can multiply 2 by anything. And if I had, let's try another one. If I had the square root of 3x minus 6, then we would say that 3x minus 6, again, has to be greater than or equal to 0. It goes back to this idea. So that then tells me if I solve, 3x is going to be greater than or equal to positive 6 when I add. And x, I'm divided by a positive, so it's greater than or equal to 2. So just take what under the radical, or in the rational form, we would take what was in the denominator and set it equal to 0. So let me show you what I mean by that. 1 over x plus 1. So this is what causes me problems. I can't be 0. So x plus 1 can't be 0. So we have x is equal to, or cannot equal, negative 1. And in interval notation, just a reminder, interval notation would say that I have negative infinity up to negative 1, but not including it, and then union, and I would start again at negative 1, so negative 1 to positive infinity. Okay, so this is all one problem. Over here, if I were to put this in interval notation, I would have x is greater than 2, so I start at 2 with a bracket because I can include it, and it goes to infinity.